Lesson 5-6. We are now talking about graphing proportional relationships. Our essential question is, what are the 3 indicators of proportional relationships? We're going to master that today, the 3 of them. So let's jump right into the lesson. How to graph review. Now you guys know how to graph, so this is just a review, a simple review. So you're supposed to locate the origin. You also have to know what the x-axis is and the y-axis, and those are all right down here. Here is the origin, we're at 0, 0. Here is the y-axis, and this is the x-axis. All right, let's start. Number 1, plot points, connect points in order. So we have our x and our y's, and so we're going to make points 2, 3, 4, 6, 6, 9, and 8, 12. We'll go over to our graph, and we'll start with our first value, which is an x value. So we're going to go, it's positive, so we go to the right 2, and then up 3. Make your point, your perfect point, right on your intersection in the background. And then 4, 6, and then you're at 6, 9. And you can already see in a proportional relationship, as we know, we have straight lines. All right, so there they are. So we are going to go ahead and make our line. Got a cheating tool there for myself. You're going to want to use a straight edge, your side of your ID card or something straight to sketch that line. Now number 2, plot points, connect points in order. So we have another set here. We're going to do 1, 3, 2.5, 6. That will be a tricky one. 3, 7, and another tricky one, 5.5, 12. So in this one, I'll change colors. And this is going to be 1, 3, and then 2.5, 6, so 2.5, and then 6. Right, halfway between 2 and 3 at 6, and then we'll do 3, 7, 3, 7, and then we'll do 5.5, 12. That's right there. And then we'll make our line, lining up our straight edge. And you can see it's not going through the origin. So what's the difference that we're looking at here? Well, this one over here, if you were to find all your ratios, as we did in the last lesson, 3 divided by 2, 6 divided by 4, 9 divided by 6, and 12 divided by 8, you would find out in all instances, the answer comes out to 3/2. And so that is consistent. So that means that this is a or proportional. Whereas this one down here, if you were to set it all up with your y divided by x's, 3 divided by 1 is 3. Then the next one is 6 divided by 2.5. Throw that into the calculator. You can probably tell before you even do the math that it is not equal to 3. So 6 divided by 2.5 is 2.4. So right away, since we already have something that's not matching, we know that this is not pro. All right. So that is the difference. Difference number 1 is straight lines and going through the origin. And you can tell that our second line is not going through the origin. It's actually missing the origin. It's right there. All right, on to the next part. Criteria of a proportional relationship graphed. All right, there are 2 ways. 2 ways to tell if a graphed relationship is proportional. Check to see that all the ordered pairs coordinates ratios are equivalent. This is just like yesterday or our last lesson. And so on this one, we have some points already listed in the graph. And if you look carefully, we have to find out what they are. Our very first point is listed right here. That's at 1, and you go up. These are going by 2s, so you got to know that it's 2, 4, 6, 8. That's 1, 8. So in our first box, we're going to put coordinate 1, 8. And when we take our y and we divide it by our x, we get 8. Let's do another. Our next coordinate is 2, and that's going to be 10, 12, 14, 16. 2, 16. So 2, 16. And 16 divided by 2 is also 8. So we're on a streak so far, but we need to do all of them just to make sure. So the next one we're going to be handling is 3, and that's going to be 24. So 3, 24, and 24 divided by 3 is again 8. And we work our way all the way to every point that is listed on the graph. Our next one is 4, 32. So 32 divided by 4 is 8. Our next one is 5, 40. And 40 divided by 5 is 8. And our last one is 6, 48. And that's 48 divided by 6 is also 8. So we have a streak here. Every single ratio is 8. So they are all equivalent. And that's what this said. Check to see that all the ordered pairs or coordinates ratios are equivalent. And they are. So we know it's proportional. Number 2, check to see the points are linear. Use a straight edge. Now that's a must. If you have something that's curvy or you're freehanding, you may not see it. So make sure you use a straight hand. Remember, linear means straight. Is the line straight? So we will start at a point and connect along. I'm trying to get it through the origin here with my tool. Not working, so let me try it again. There we go. All right. So it looks like it does. A straight line covers every single point on the graph. And number 3 says check to see if the line goes through the origin. And you can see that this line is going right exactly through the origin. So let's write down origin there. Now, in these directions, there's 2 ways mentioned. Here is one way, and here is the first way. So you have the first way option, and you have the second way option. If all criteria are met, then it is a proportional value. So it is straight, it is going through the origin, and all of the ratios are equivalent. So therefore, this is proportional. Whoops, try that again. All right, next page. Let's try it. Identify which of the following are proportional relationships. So you can barely see it. I don't know if you can see it on your notes, but on here you can. You find a point, and then you line up your straight edge, and you connect all the points. And if all the points are being covered by your straight line, and it's going to the origin, as it's doing here, you know that A is proportional. So we'll just write pro next to it. How do we know that? Well, it's straight, and it's going through the origin. Let's take a look at letter B. This line is straight, but it is not going through the origin. It's passing through the y-axis at 5. So this one is not pro. Let's take a look at C. C has points, so we're going to draw a line connecting all the points, a nice straight one. You can see I can't do it because as I move, I'm moving off of others. So there's no way to draw a straight line here. So what can be drawn though is I can connect them all one by one with straight lines. There's a straight line, straight line, straight, and straight. And that looks like the curve now. And that's not straight, nor is it going through the origin. So this is another not proportional relationship. And our last one, it looks to be straight. Use a straight edge to look at it very closely. And it is straight, and it does go through the origin, so this is another proportional relationship. Because it goes through the origin, and it is exactly straight, or linear. Writing an equation from a graph proportional relationship. Now you've had some experience with this in Unit 3, and we're just kind of a review here. So let's make sure if you struggled back then, we're going to get this down. Before we begin, yesterday, or not yesterday, on the previous lesson, we learned all about the proportional equation. And that is y is equal to kx, where k is the COP, the constant of proportionality. All right, how do we find that? Well, we do y divided by x is equal to k. And we check every one to make sure that all the k's are the same. All right, so let's go ahead and do number 1 here. Find the perfect spot. Now, this is something you need to know, especially for your assignment. This spot right here is very perfect. That point is on an intersection. When we say intersection, we mean it's exactly on one of these vertical lines and one of these horizontal lines. It's lined up exactly on it. Let's look at some of the others that this graph offers. If you look at this one right here, it's off of it right there. It's not a good point. So let's not use that one for accuracy. So I'll erase that one. Where's another one that's inaccurate? How about this one right here? It's close, but it's not accurate. It needs to be just like this one right here. That one is very accurate. All right, so let's go ahead and do what it says. Find an intersection that the line passes through with accuracy. One's already listed. Sometimes there are more than one point you can use. We did find an additional point. Number 2, note both the y value and the x value of the perfect point. They are found in the coordinate or order pair. So let's go ahead and note it. So our notes are, for our first point right here, we're going to call that 16, 12. And our second point that we found was 8, 6. Remember, make sure you list the x value first. All right, number 3. To find the k value, or the COP, divide y by x. So on this one, we're going to divide our y's. 12 divided by 16 is 3/4. It's a fraction that's simplified. We don't want to go to decimals. Fractions are easier to work with. Let's do the next one. 6 divided by 8 is also 3/4. So it looks like we have equivalence there. We do know that it's straight, and we see that it goes through the origin. So it is a proportional relationship. Now let's write our equation. It's going to be y is equal to the k value that we found of 3/4 x. Now it can also be written as this: y is equal to 0.75x, which 75/100 is the same thing as 3/4, but this would be the preferred method since we're dealing with slope. It's easier to work with. All right. Try it out. Write an equation for the following proportional relationships. So take a look at this first one right here and see if you can write an equation for this line. Remember, you're looking for perfect points. To get you started, you can see it does go through the origin. It is straight, and there's a perfect point here and here. So pause the video and try to write an equation for this line. Pause now. And here we are back. Did you end up with an equation like this, y equals 2x? Hopefully you did. To find that, you need some perfect points. Here's one and here's one. I recorded what the points were. I did my y divided by my x, and I got my k value. And I did it twice to make sure my k's were correct. It is straight. It does go through the origin, so I know it will work. So go ahead and pause the video and try the last two. Pause now. Here are the two answers. Y equals 4/3 x and y equals 1/4 x. Remember, when you are working with your k values, make sure they are in simplest form. Now this is improper, but it is in simplest form. This is proper and it is in simplest form. So make sure you do that. All right, let's go down here to this paper and see what it's all about. Use each description to complete the table representing that person's journey. The bumper cars are 50 meters away from the ticket booth. You may need to remember that. A. Diego left the ticket booth at the same time as Tyler. Diego jogged ahead at a steady pace and reached the bumper cars in 30 seconds. And then B. Lynn left the ticket booth at the same time as Tyler. She ran at a steady pace and arrived at the bumper cars in 20 seconds. And then C. Tyler left the ticket booth at a steady pace and reached the ticket booth in 40 seconds. So we have three tables here. We have Diego's, Lynn's, and Tyler's. So what we're going to do for the notes, we're going to just color code things. We're going to call Diego the yellow one. We're going to call Lynn B, the green one. And then we're going to call Tyler the blue one. Just so in the notes you can see what is happening. All right. These notes down here have missing information. But up here inside the words are some super serious things. So it says, in this case, Diego jogged at a steady pace. That means he didn't speed up, he didn't slow down, it was consistent. You can also see that in Lynn's paragraph. It also mentions a steady pace. And then in Tyler's, it also mentions a steady pace. So they're not speeding up, they're not slowing down, they are being very equivalent in their ratios. So if you go down here, you can find their k values. You'll find Diego's right here, you'll find Lynn's right here, and you'll find Tyler's right here. That's the information you need. So starting with Diego, and then you'll pause the video and do Lynn's and Tyler's. Diego's, this is our x column and this is our y column. So this is 50 divided by 30. And that is 5/3. So 5/3 is going to be our k value. So our equation for Diego is going to be y is equal to 5/3 x. And now we just use this to fill in the rest. We'll multiply 0 by 5/3. And of course it's going to be 0. Notice that's 0, 0, and that is the origin. We'll multiply 15 by 5/3. We'll do some cross cancellation here. Once and 5 times, that's going to be 25. And then we'll multiply 1 by 5/3 and get 5/3. Now we'll come down here and I'm going to use, let's see, yellow. Hopefully that will show up for you for Diego's. And my first point is 0, 0. So come down here and I'll put a 0, 0 for Diego. Then my next point is 15, 25. It's 15, 25. So I'll come up here and I'll go 15, then up to 25, make my points. And then 30, 50, 30, 50. And then I had one more. I had 1 5/3. So that's going to be a tough one because there's no 1 right here. So 1's going to be estimated about there, and then 5/3 is going to be about right in this area. But it's very different, well, about right in this area. It's very difficult to do those because you don't have a good graph to do such small numbers. So let's go ahead and draw our line for Diego. Trying to get there. Can't quite get there. That's close, but not good enough. But we'll try it again. That's closer, but still not very accurate. See how this is off a little bit? So try to make your lines right on your points. Okay, so that's how you do it. Go ahead and pause the video and fill in Lynn's graph and Tyler's graph, and then graph those two lines on this same graph. Pause now. All right, we're back, and you can see Lynn's line is in black for me, Diego's is yellow, and Tyler's is blue. All right, now as we compare them, you can see that Lynn is the steepest line, Diego's is the middle line, and Tyler's is the least amount of steepness. So, how can you compare these three lines? If you look at, let's say 10 right here, 10 is represented as the elapsed time. So at 10 seconds, and you look straight up, it took Tyler was able to do the distance from the ticket booth meters. So he covered the least amount of ground in 10 seconds. You can see right here that Diego covered a little bit more ground, but Lynn was the fastest one getting to the bumper cars. And that's what that's for. You can compare these things. As the slope increases, the rate is increasing. And you can also see that back here when you look at the K values, which is also known as the slope. All right, put your first name, your last name, the date, and the period. For number 1, it says which graphs could represent a proportional relationship. And so what you're looking for is something that's straight. There's 3 of them that are straight. There are 3 of them that go through the origin. So which ones are proportional? It looks like A and C are both proportional. You'll do 2 on your own. Number 3 says decide whether each table could represent a proportional relationship. A, the sizes you can print a photo, and B, the distance from which a lighthouse is visible. Now, this one doesn't offer a graph, so you're going to have to find the ratios of each. I'll get you started, and then you'll finish it. This is our X column and our Y column. This is 3 divided by 2, which is 3 halves. This is 6 divided by 4, which is also 3 halves. You'll check all of them to make sure that they are equivalent. If they are, it is a proportional. If they're not, they are not a proportional. You'll do the same thing down here for B. This is your X column, this is your Y column. So 6 divided by 20. And you just simplify that. 6 divided by 20, 2 goes into both. So it's 3/10. And you'll work your way down just like that. You'll do number 4. Number 5, it says match each equation to its graph. So on this one, on number 5, you can see it goes through the origin. It is straight, as well as all the others. And so down over here, you have all of your equations. Well, one of these equations matches number 5. So you have to figure out which one. If you blow this up, you can see that it gives you a perfect point right here. And that perfect point is at X is 1, where my Y value is not quite 1. It's going by tenths. And that's 2/10, 4/10, 6/10, 8/10. So 8/10. To find your K value on this straight line, well, there's also one over here. That one is 5. Looking back is 4. So take your value 4 divided by 5, and looks like that simplified is 4/5. So we're looking for an equation that looks like this: y equals 4/5 x. So you look over here, and you can see that b is the 1. So b belongs to number 5. So you'll do that on all of those. And then on number 11, it says determine whether the relationship shown is proportional by graphing on the coordinate plane. So remember, this gives us our x column and our y column. And so our point here is 1, 4, 2, 8, 3, 12, and 4, 16. So we'll come down here and we'll graph these points: 1, 4, 2, 8, 3, 12, and 4, 16. You'll line up your straight edge. It's covering all those, and it's going through the origin. So it's straight and goes through the origin. So determine whether the relationship shown is proportional by graphing. So we did, and it is proportional. In addition, let's find out what our equation is to this. So if you do 4 divided by 1, you'll get 4. 8 divided by 2 is 4. 12 divided by 3 is 4. And 16 divided by 4 is also 4. So our k value is 4. So for an equation, we'll write y is equal to 4x. And then you'll do 12.